Well, hello everyone. It's a pleasure to be here. So far, in a way, we have talked about AI and its different areas, but an important point that is actually the end of this chain is decision making. Today, I want to delve more into this subject. I'm Ehsan Maminejad, and I've graduated in electrical control engineering, and then for some time I was industrial automation, and then I was in management counseling companies. And in those companies, we were dealing with decision making or data, and there were some interesting challenges there. And after that, I decided to go into data science and AI, and I passed a course in data science, and I was in that area from engineering to data science. But the question that was raised up for me in that process is it really possible to make the model the decision making with engineering accuracy? Today we want to talk about this. Well, about decision making and modeling it, sure, we hear the name of Daniel Kahneman. It's one of the first names that comes up to our name. He is a psychologist that got the Nobel Prize in the area of behavioral economics, and the thing that he did in this area led them to win the Nobel Prize. And what we hear about their book, and they believe that nobody is on the planet that understood that the human's decision making. And he introduced two types of decision making: System 1 and System 2. System 1 is a fast system, observatory, and automatic. This system in the process of our decision making is evolved through our evolution. Prime humans, when it was to decide in a situation of fight, flight, or freeze, has developed this, and it's automatic. We have another system in our mind that Daniel Kahneman named System 2. It's slow, logical, and analyzer. And about the difference between these two systems, I have a question here. Five machines produce five products in 5 minutes. Now, how many devices do we need for 100 products in 100 minutes? How many times does it take to for 100 devices to produce 100 products? Our system 1's response would be 100, but the actual answer is 5 minutes, because every machine takes 5 minutes to produce. So the 100 machines would produce that in 5 minutes too. But when we are talking about System 1 and we are talking about data analysis and talking about data, humans are always dealing with cognitive errors, because we're always dealing with emotions and feelings. When you are analyzing a subject and you're taking it to the person who is going to make decision about it, the way that the person looks to you is affected by in the way that they make decision. Here I have some cognitive mistakes and errors so that we can get to know the subjects better. We have confirmation bias, availability bias, anchoring effect, and representativeness bias. For example, confirmation bias. Imagine if I have this confirmation bias, I'm always looking for data that approve the decision that I made. For example, anchoring effect, I get attached to something and my mind makes an anchor on that, and when I see those data, my decision would go wrong. But why this happens, it gets back to our evolution and laziness of our mind. Our mind, in order to process the processes, is gone for making everything optimized, and our mind, in terms of energy, and using energy, has a low power. It's around 20 watts. But in order to do better in data analysis in the area of AI, the solution is to be aware of our mind. Well, now we mentioned these cases, and in the process of AI's development, we always take patterns of AI, of humans' brain. But the question is, can we make a system that can make decisions without these errors, or at least with a better accuracy? If we observe the process of AI's development, it seems that AI started from a System 1, amateur System 1, and has moved towards System 2. In 1980, that CNNs were invented. They were based on learning. And then we had deep learning, and then we had transformers and birds. We had some discussions about do we have this intelligence, and that went on to what we have today. And now, because I already said I'm not gonna mention them. I want to talk about learning versus reasoning. We have learning versus reasoning. If you're familiar with this area, we say statistical learning or machine learning. Learning is based on past data. And what are the problems? One of them is that the machine cannot understand deep subjects. And if I have a explanation and I have trained my machine on that explanation, if another explanation comes, my machine would not understand it. But in reasoning, pretty much this problem is solved. In the area of the topic of reasoning, we have a topic called NP complete. When the complexity of the subject gets higher, the time that it takes for the machine to process that should be higher too. If machine does another way than NP complete, it would give a wrong answer. If I want to solve this challenge, they've used structures or different engineerings. One of the subjects here is chain of thoughts and also tree of thoughts. To create a chain of thoughts in that machine, or create a tree of thoughts in that machine, so that here we have the engineering here on this slide too. Here, that kind of engineering have applied that on GSM8K. Normally, it has the accuracy of 80% in the standard prompting, and when they applied it, its accuracy raised up to 50%. So now we said that System 1 has its own challenges, and are going towards applying and using System 2 so that we do not have those cognitive errors that we have in humans. And all the things that we did are about so generally we added reasoning in the C part. In addition to that, we added memory so that we can model human on machine. So we had a complete model that it gives feedback, and based on its reasoning and its memory, it takes some actions. Now that we have made this, in order to solve the issues for complex systems, for example, catching cheatings, or the things in the stock market that are complicated issues, we had now we have multi-agents. Now we can make multiple agents and give them multiple rules, so that their decision is again decided by another bigger agent. Actually, today I try to wrap up the things that I explained here by saying that how does humans' mind work, how we make decisions, how are we gonna use AI and its path from learning to reasoning, and has made that learning and reasoning in itself, and in the end making that decision. Thanks for your attention.